Hello, welcome to Engineers Mindset. Alright, so let's consider the question on the board. We are given f of xy equals x squared y cubed plus y squared sine inverse of x over y, and we are asked to find the partial derivative of this function f with respect to y. Okay, so what I will do is actually to break these functions down because I'm having combinations of both x, y cube and then sub addition, and then again a multiple function between y squared and then sine inverse of x over y. So I will simply say let a be equal to x squared y cube and b to be equal to the second function here, which is y squared sine inverse of x all over y. So if I have this now, it means simply that this function now this function f of xy is now simply equal to, in place of x squared y cubed, I simply call that a. So it becomes a plus, in place of y squared sine inverse of x over y, I call that b. So this simply become a plus b. Alright, so the derivative of a sum is actually the sum of the derivative. That simply means if I differentiate this function now with respect to y, it is actually what? Differentiating a with respect to y plus differentiating b with respect to y. That's all what this statement means. Okay, the derivative of a sum is actually the sum of the derivative. So if I differentiate this function with respect to y, it actually means I'm differentiating a with respect to y. I'm also differentiating b with respect to y. So all I need to do is simply differentiate a with respect to y and then differentiate b with respect to y. Plug it into this equation and I'm done. Okay, now from a, okay, let's do that here. From a equals x squared y cubed, I want to differentiate a partially with respect to y. From the law of partial derivative, if I'm differentiating a function with respect to another function, I'm going to keep the function which I'm not differentiating with respect to as a constant. I want to differentiate a with respect to y, which means I'm going to hold x squared as a constant because I am not differentiating with respect to x. So I'll keep x squared as a constant, and if I differentiate y cubed, I will simply have 3 times y, 3 minus 1. So simply use the power to multiply the variable y, then remove 1 from the power. That becomes the derivative of that function. Okay, so partial a all over partial y is actually equal to x squared times, of course, this becomes 3y. 3 minus 1 becomes 2. That gives us 3y squared. So this simply implies that the partial derivative of a with respect to y is actually equal to 3x squared y squared. So you keep this function aside. Okay, so this part of the equation have been determined. Next is to find the partial derivative of b also with respect to y. Okay, so let's pull it out now. So from b is equal to y squared sine inverse of x all over y. Notice now that b is actually a multiple of two functions. I'm having y squared multiplying sine inverse of x all over y. So which means I'm actually going to employ the product rule to solving this equation or to solve this derivative. Now, the very easy thing to do is from product to remember, you simply say let u be equal to y squared and let v be equal to sine inverse of x all over y. Okay, so if you establish this now, this actually now implies that b itself is now equal to, we called y squared to be u, so you simply have u times, you call the whole of this variable sine inverse of x over y to simply be v, so it becomes u dot v. So which means b is a product of two functions, and as such we are going to employ the product rule to solving this partial derivative. All right, so Now, recall from product rule, okay, from product rule of partial derivative, okay, if I want to differentiate b with respect to y, that's simply partial b all over partial y is simply equal to, from the product rule, you keep u constant, differentiate v partially with respect to y, that simply gives you u partial v all over partial y plus, now you keep v constant and you differentiate u with respect to y. So you simply have v partial u all over partial y. So you have this. So all I need to do now is simply what? Find the partial derivative of v with respect to y and also find partial derivative of u with respect to y. Plug into this equation, then you're good to go. You've obtained the partial derivative of v with respect to y, which is this aspect of the equation. Okay, now from u equals y squared. Okay, from u equals y squared. If I differentiate u partially with respect to y, that simply gives me, you use the power 2 to multiply the function y, then you subtract 1 from the power, it becomes 2 minus y. So this now implies that the partial derivative of u with respect to y is actually 2y. All right, so we've gotten this part, partial u partial y. Now we need to obtain partial v partial y from v equal to sine inverse of x all over y. Okay. Okay, so let's consider when v is equal to sine inverse of y. All right, so from v equals sine inverse of x all over y. Okay, let's have this now. Now, this is actually an inverse trigonometric differentiation. So what we'll do is, to be able to break this down, you should simply say, you can use any alphabet now. You can say let u be equal to x all over y, which is simply the angle in front of the trig function. So this now implies that v itself is actually the sine inverse of u. So from here now, I have that u is a function of both x and y. From here, u depends on x and y to be defined. Okay, and from here, v is a function of only u. So which means I can differentiate v partially with respect to u alone. But in this case, u is a function of both x and y. That means I can differentiate u with respect to either x or either y. But the equation is asking us to differentiate with respect to y. So which means we are going to be keeping x as a constant and differentiate this function with respect to only y. But then from here, v is a function of u, which means I can only differentiate v with respect to u. Therefore, if I differentiate v partially with respect to u, I'm simply going to have 1 all over square root of 1 minus u squared. Because this is inverse trigonometric differentiation, so the derivative of sine inverse of u becomes this. Okay, but then remember, recall you said u is equal to x all over y, of course, and this can also be written as x y to the power of minus 1 is still the same thing as this. All right, so it means in place of u, we can now obtain that the partial derivative of v with respect to u is simply equal to 1 all over the square root of 1 minus x y minus 1 all squared. In place of u is simply x over y, which is something as x y to the power of minus 1. Okay, so you can have this. All right, so this becomes a partial derivative of v with respect to u, but that's not what the equation is saying. We need to find the partial derivative of v with respect to y. Okay, once we obtain that and then we put that in that equation, we are good to go. Okay, so what to do from here now is we'll find partial v partial u. Next is to differentiate u with respect to y and employ the chain rule to find the partial derivative of v with respect to y. Okay. So I'm going to wipe this part of the board now to create space, but just keep this equation in mind because this is what we are looking for. The partial derivative of f with respect to y is simply partial a partial y plus partial b partial y. So keep this equation in mind. We'll come back to it. All right. So from u is equal to x all over y, which I also say this can be broken down to u equals x y to the power of minus 1. I will now differentiate u with respect to y, and that's equal to, now since I'm differentiating with respect to y, I will simply keep x as a constant. If I do that, I will differentiate the power. Differentiating y now, differentiate the power, use the power minus 1 to multiply y, then subtract 1 from the power, it becomes minus 1 minus 1. So I have this, okay? So it means that the partial derivative of u with respect to y is now equal to, this becomes, of course, minus 1 times y, simply gives us minus, okay, times x, y to the power of minus 1 gives us minus 2. So this becomes the partial derivative of u with respect to y. But we are looking for partial derivative of v with respect to y, not forgetting, we are looking for partial derivative of v with respect to y. So therefore, partial v partial y, we simply employ chain rule. From chain rule, from the chain rule, okay, we can have that the partial derivative of v with respect to y is actually a product of the partial derivative of v with respect to u multiplies partial derivative of u with respect to y. So notice here, partial u can cancel partial u. You're simply left with partial v all over partial y. Okay. Okay, so this is now equal to partial v partial u. We obtain that function here as 1 all over square root of 1 minus x y to the power of minus 1 all squared, which is simply 1 all over root 1 minus x y to the power of minus 1 all squared, okay, multiplied by partial u partial y, which gave us simply this minus xy to the power of minus 2. So this simply implies now that the partial derivative of v with respect to y itself is now equal to, okay, becomes minus x y to the power of minus 2 all over the square root of 1 minus x y minus 1 all squared. So this becomes the partial derivative of that function, okay, with respect to y. So if we know partial v partial y, all we need to do is simply what? Substitute into this equation partial v partial y, and we know partial u partial y already from here, then obtain the partial derivative of v with respect to y, then we can plug back into our given original equation, okay? All right, so I'm going to do that over here. Let me take this off, okay? Let me take this off. I'll take this down a bit, partial u partial y, partial u all over partial y, we obtain this as 2y. Let me take it down. All right, so I'm going to do the whole of this here now. The partial derivative of b with respect to y becomes now, okay, so partial b all over partial y is now equal to, so from the law, keep u constant, differentiate v with respect to y, and we said let u be equal to y squared. So simply keep y squared constant, okay, differentiate v with respect to y, and partial v partial y give us the whole of this variable here, or that expression. So we simply have minus x y to the power of minus 2 all over the square root of y minus x y to the power of minus 1 all squared, okay, plus, now you keep, from the law, now you keep v constant, differentiate u with respect to y, and v, we said let v be equal to sine inverse of x over y, so keep that constant, sine inverse of x all over y, differentiate u partially with respect to y, and partial u partial y simply gave us 2y. So multiplied by simply 2y, we have this. Okay, so let's continue over there. We can now have that the partial derivative of b with respect to y. So please take note, this becomes y squared multiplies the whole of this numerator. I will simply have minus x y to the power of minus 2 times y all squared all over the square root of 1 minus x y to the power of minus 1 all squared, okay, plus I'll have the other side, it becomes, okay, plus 2y sine inverse of x all over y. So I'll simply have this, okay, so partial b all over partial y is now equal to, if I evaluate this, I'll have minus x. Now I have y multiply y to the power of minus 2 multiplying y to the power of 2. You have two functions having the same base. From the law of indices, pick one of the function and add their powers. Since they have the same base, I simply pick y, add their powers. The power here is minus 2 plus the power here is 2. Okay, all over the square root of 1 minus x y to the power of minus 1 all squared plus 2y sine inverse of x all over y. Okay, from here, I will simply have that the partial derivative of b with respect to y is now equal to, of course, y to the power of minus 2 plus 2. Minus 2 plus 2 is simply 0. So I'm simply left with y to the power of 0. And any variable or expression raised to the power of 0 is actually equal to 1. So which means this is off. So I'm left with minus x all over the square root of 1 minus xy to the power of minus 1 all squared, okay, plus 2y sine inverse of x all over y. So this becomes the partial derivative of b with respect to y. So I'm going to now take us back to the very first function. Remember, the very first function which I said you should keep in place. Let me wipe here now. So recall from the beginning we said that partial f all over partial y is actually partial a all over partial y plus partial b all over partial y. So obtain what partial a partial y is, we'll find what partial b partial y is, we simply put into this equation. This now implies that partial f over partial y is now equal to partial a partial y, give us here as simply 3x squared y squared. So we'll put that down, 3x squared y squared plus partial b partial y simply gave us this. So minus x all over the square root of 1 minus x to the power of xy to the power of minus 1 all squared, okay, plus 2y sine inverse of x all over y. Okay, so of course we have negative function here. Negative and plus becomes negative. This now implies that the partial derivative of this function with respect to y is simply equal to 3x squared y squared, okay, plus it becomes minus now, minus and plus becomes minus x all over the square root of 1 minus x y to the power of minus 1 all squared, okay, plus 2y sine inverse of x all over y. So you have this to be the answer to that partial derivative. All right, guys, I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And of course, if you are new to the channel, please don't forget to hit the subscribe button to keep getting updates when videos like this keeps dropping. I will see you in the next video with more and more amazing problems on partial derivative. In the meantime, thanks and cheers.